Hello, today we're going to learn about radicals. And what radicals are square roots. Now, if we are going to add square root or 3 root 7 plus 5 root 7, this is similar to adding 3x and 5x. It uses the same property. If these are the same values, we add it to be 8 square root 7. Just like if we have 7 root 2 plus another root 2, that's like a 1 root 2. So that would be 8 times the square root of 2. If I have 9 root 3 minus 7 root 3, you subtract the 9 and the 7, so this becomes 2 times the square root of 3. Now if I have 12 root 5 minus 5 root 2, since our square roots are not the same, we can't subtract them, so this is as simplified as we can get it. When we multiply radicals, we can multiply things that are outside the square root with things that are outside the square root, things that are inside the square root with things that are inside the square root. So 2 can't be multiplied by anything, but the 5 and the 2 could be multiplied together to get 10. So 2 times the square root of 10 is that answer. Similarly, 8 cannot be multiplied by anything, but root 7 times root 3 is root 21. So our answer is 8 times the square root of 21. Now when I multiply these, I can multiply the 5 times the 3, but not, you can't, since that's outside, you can't multiply that to the 2. So this will be 15 times the square root of 2. Now here the 3 can multiply by the 7 to get 21, and the root 5 can multiply by root 11 to get square root of 55. Now if I am going to square cube or root, that's like 2 root 3 times 2 root 3, which 2 times 2 is 4. Root 3 times root 3 is root 9. So that's 4 times 3, which is 12. Now, if there's an addition in here, then I'd have to multiply to each section. So 4 root 3 times 2, I can multiply the 4 times the 2 to get 8 times the square root of 3. 4 root 3 times root 6, that's going to be 4 times the square root of 18. Now if I multiply these radicals, this one will go over the parentheses, and so will that. So square root of 2 times square root of 2, that's going to be square root of 4, so 4 root 4. Root 2 times root 3, that's the square root of 6. Now we can actually simplify this a little bit more, because the square root of 4 is 2. So this is like saying 4 times 2 plus root 6, or 8 plus root 6. Dividing radicals, we do the same thing. If it doesn't have a square root, you can only simplify it with something that doesn't have the square root. So 10 over 2 would be 5. So we'd leave this 5 times the square root of 8. Now, you should know all of your perfect square numbers. 1 squared is 1, so the square root of 1 is 1. 2 squared is 4, so the square root of 4 is 2. And so on all the way down. Now what this shows us is that squaring and square root are inverse operations. What that means is these operations undo each other. So squaring and square roots do the opposite things. So if I keep working this down, that's 64, root 64, 81, root 81, 100, root 100, and 121, and 144. Now, everybody should have, 121, 144. Everybody should have square numbers memorized from 1 through 144. If I ever ask you find these square numbers, these are the things I'm looking for. Now, one property that we can get from this, since we say that these two undo each other, if I have the square root of 16 squared, that's going to be 4 squared which equals 16. So if I have the square root of 53 squared, now I can't find the square root of 53, but if you notice, this 16 is what the answer was, because these undo each other. So this answer would just be 53. All right, now we're going to use those perfect squares to simplify a radical. Now this is a new concept. What this means is we want to take anything that's a perfect square out of this 18. Now we look for any perfect square that divides evenly into 18. And we know 9 does, so we can rewrite square root of 18 as the square root of 9 times the square root of 2, because 9 times 2 is 18. But the square root of 9 is 3, so we simplify this to being 3 times the square root of 2. This is considered simplified form. If I have root 32, the number that we can take out is square root of 16. So the square root of 16 times the square root of 2. The square root of 16 is 4. So 4 times the square root of 2 is the answer. Square root of 75. 25 goes into 75. So this is the square root of 25 times the square root of 3. So the square root of 25 is 5. So our answer is just 5 times the square root of 3. Square root of 108. Now this square root of 36 goes in times 3. So this would be 6 root 3. Now I want to pause for a second and say, if you didn't get that, say if you took out a 4. Say you said square root of 4 times square root of, what would that be, 28. No, not 28. 104. I should have my division down. 27. Now, the square root of 4 is 2. 2 root 27 is not the same as this, because the square root of 27 isn't simplified. We can take another root 9 out, so this would be 2 times 3 root 3, or 6 times the square root of 3. So you can get this answer if you don't pick the biggest one right away. It's just a little bit longer process. If I have the square root of 12, this is going to be the square root of 4 times the square root of 3, which will equal 2 times the square root of 3. Square root of 24. Now, all of these, I would hope for you to pause the video and see if you can do this one on your own. Hopefully you're done, and you got the square root of 4 times the square root of 6, which is 2 root 6. Square root of 40, I would pause the video. Hopefully you're done with the problem. This is root 4 root 10, so this would be 2 times the square root of 10. Square root of 48, this would be square root of 16 times square root of 3, or 4 times the square root of 3. Square root of 21, now this will be the square root of 7 times the square root of 3, and you can't break anything down any further, so square root of 21 is all we got. Now that we know how to simplify, before we would say we couldn't add these because they don't have the same square root. But the square root of 12 is the square root of 4 times the square root of 3, which is 2 times the square root of 3. So if I have 4 root 3 plus 2 root 3, that gives me 6 root 3. Same here. That's going to be root 49 root 2. So if I have 9 root 2 minus 7 root 2, that would be 2 root 2. Square root of 5 squared. Now, we talked about this earlier. The squares and square roots are inverse operations, so this answer should just be 5. Now, if I want to rationalize the denominator, what that means is I don't want a square root in the denominator. I can multiply by root 5 over root 5, because my numerator turns into 6 root 5. Root 5 times root 5 is just 5 from this preceding problem. If we wanted to do more of that type, we just have to multiply by root 7 over root 7. So we'd have 9 root 7 over 7. Now, if there's a square root of 2 in the denominator, you don't have to do the whole thing. You just have to multiply by the root in the denominator. So this would be 4 root 2 over 3 times 2, which would be 4 root 2 over 6. Now I can simplify this 4 and the 6 to be 2/3. So 2 root 2 over 3. Again, I would try this one on your own. I would multiply by root 5 over root 5, and this would be 4 root 35 over 5. All right, now you can hopefully get through the homework for today.